I still remember the first time I saw a picture of the Ouranopithecus jawbone in one of Dad's old science magazines. It wasn't shiny or impressive like dinosaur skeletons in museums. It was just a rough piece of fossilized bone, chipped at the edges, with teeth that looked way too big for something so ancient. But the caption underneath said something that made me stop flipping pages: "This fossil may change how we think about the story of human evolution." At first, that didn't make sense to me. How could a broken jaw found in Greece, thousands of miles from the famous African fossil sites, tell us anything new about where we came from? For years, the story always seemed clear: Africa was the cradle of humanity, the place where our ancestors stood up and walked. But here was this fossil, from the 1970s, suggesting that maybe we didn't know the whole story. And that, to me, was more exciting than any dinosaur. The story of Ouranopithecus begins not in Africa but in the rocky hills of northern Greece. Imagine the scene: it's the 1970s, the summer air is dry, cicadas buzzing loudly, and a group of paleontologists are digging through dusty layers of sediment near a place called Chalkidiki. They aren't expecting to find much that day, just the usual fragments of bones from ancient animals that roamed Europe millions of years ago. But then, brushing away the soil, one of them spots something unusual: the curve of a jaw, half buried, with teeth still locked inside. At first glance, it doesn't look like much. But once it's lifted carefully from the ground, cleaned, and studied, its secrets begin to unfold. The jaw is massive, the molars thick and heavy, like they were made for crushing tough foods. The scientists realize they're not looking at the remains of a monkey or some random ape. This belongs to a species never seen before, an ancient great ape that lived around 9 million years ago. They call it Ouranopithecus macedonensis, which roughly means the ape of heaven from Macedonia. I always thought that was a strange name, ape of heaven. But the more I read about it, the more I understood why it felt heavenly to those scientists. Discovering a new kind of ape that old was like opening a locked door to the past. It meant they had found a missing piece in the puzzle of evolution, one that didn't fit neatly with the pieces we thought we already understood. When I tell this story, I imagine standing in those hills with the paleontologists, the sun beating down, dust sticking to my face as I crouch over the exposed jaw. I imagine the mix of excitement and confusion they must have felt. On one hand, they had something extraordinary. On the other, it raised questions they couldn't yet answer. Was this ape just another branch of the tree of life that eventually withered away? Or could it be a relative of ours, a distant ancestor whose descendants might one day walk upright and become human? To get closer to that answer, scientists studied the jaw and other fossil fragments. They later found pieces of skulls, teeth, and even parts of the face. What they saw was fascinating. Ouranopithecus had a broad, flat face, kind of like a human's, with wide cheekbones and deep-set eyes. Its teeth, especially the molars, were huge, suggesting it chewed on really tough, fibrous plants or maybe hard seeds and nuts. It wasn't delicate or fragile, it was built to handle life in a rugged environment. But the real shock came when scientists compared these features to both modern apes and early human ancestors. Ouranopithecus didn't look exactly like today's chimpanzees or gorillas. And strangely, it also didn't look completely unlike us. Some argued that it shared traits with later hominins, the group that includes humans and our closest extinct relatives. This was the part that stirred debates. For decades, the dominant story said that Africa was the birthplace of humanity. After all, fossils like Australopithecus afarensis, famous for the skeleton nicknamed Lucy, were found in Ethiopia. These early hominins, around 3 million years old, showed clear evidence of walking upright. No European fossil could challenge that, or so it seemed. But Ouranopithecus was older than Lucy by millions of years. And it was found not in Africa, but in Europe. That led some scientists to wonder, what if the roots of our evolutionary story stretched farther than we thought? What if, before Africa became the stage for early humans, there were important chapters unfolding in Europe? Of course, not everyone agreed. Some scientists argued that Ouranopithecus was simply an extinct ape, with no direct link to humans. They pointed out that many ape species lived and died without leaving descendants. Evolution, after all, is a tangled tree with branches that split, grow, and sometimes vanish. Just because an ancient ape looked a little like us didn't mean it was our ancestor. Still, the possibility was too intriguing to ignore. I remember reading one article that said, if Ouranopithecus is connected to our lineage, it would mean the human story began in Europe, not Africa. That one line made me sit back and stare at the page. Could that really be true? If so, it would rewrite everything I had learned in school about human origins. I think what fascinated me most was not whether the theory was right or wrong, but how a single fossil could spark such big questions. One jawbone in the dust made scientists rethink the entire map of human evolution. It made me realize that science isn't just about having answers, it's about asking better questions. The discovery also got me thinking about the world 9 million years ago. Greece wasn't the same place we know today, full of olive trees and blue seas. Back then, it was a patchwork of forests, woodlands, and open areas. Herds of ancient animals wandered there: giant deer, early horses, and strange relatives of elephants. In that landscape lived Ouranopithecus, climbing trees for safety but also moving across the ground in search of food. Maybe they traveled in groups, grooming each other, calling out with deep voices that echoed through the forest. We don't know for sure, but imagining it makes the fossil feel alive. When I try to picture it, I see a small group of them resting under a tree. One of them cracks open a hard fruit with its powerful jaws, while another keeps watch for danger. A youngster swings from a low branch, curious and playful. They don't know, of course, that millions of years later, humans will find their bones and wonder if they were somehow part of our story. They're just living, day to day, like any animal trying to survive. That's the strange thing about fossils. They're silent, and yet they speak volumes. The Ouranopithecus jaw doesn't tell us everything. It doesn't show us how they walked, how they cared for their young, or what sounds they made. But it whispers enough to make us lean in closer, to ask what role this ancient ape played in the long chain that eventually led to us. And here's where the real shift happened. Before fossils like this, most people thought of human evolution as a straight line. First there were apes, then came something a bit more human, and finally there was us. Simple, neat, and easy to understand. But Ouranopithecus and fossils like it showed that the truth was much messy. Evolution wasn't a line, it was a branching tree, with many experiments, dead ends, and surprises along the way. That was the beginning of a bigger change in thinking. No longer could scientists just focus on Africa alone. They had to widen their search, to consider that the ancestors of humans might have traveled, adapted, and even shifted between continents long before Lucy ever walked. Ouranopithecus wasn't just a fossil, it was a challenge, a dare to look at the past differently. Sometimes, when I look back at that magazine page, I think about the paleontologists who lifted that jaw from the dust. They couldn't have known how much debate it would stir, or how it would push people like me to imagine a whole world long gone. But maybe that's the beauty of science, even the smallest discovery can echo across decades, changing how we see ourselves. And so, the jaw of Ouranopithecus didn't just sit in a museum drawer. It made scientists argue, question, and rethink. When I first saw the reconstruction of Ouranopithecus's face, I couldn't stop staring at it. The drawing showed a wide, flat face with big cheekbones, a heavy brow ridge above deep eyes, and a mouth framed by huge teeth. It wasn't exactly human, but it wasn't exactly ape either. It looked like something caught in between, a shadow of what we might have been, or maybe what we could have been if history had unfolded differently. I leaned closer to the picture in the book, trying to imagine the face in motion. Did those eyes glint with curiosity like mine? Did it raise its brow in surprise, or bare its teeth in warning? What sound would it have made if it was angry or afraid? The fossil itself, of course, can't answer those questions. But the bones give us clues, and clues are what scientists live for. The most striking thing about Ouranopithecus, apart from its giant molars, was its face. Compared to today's chimpanzees and gorillas, its face was unusually flat. Chimp faces jut forward, with long jaws and protruding mouths. Ours, on the other hand, are flatter, with tucked-in jaws and smaller mouths. Ouranopithecus sat somewhere in between, flatter than an ape, but not as tucked in as us. That feature alone was enough to make paleontologists sit up and pay attention. Why? Because flat faces are one of the traits linked to the human line. Somewhere along our journey from ape-like ancestors to modern humans, our faces became shorter and more vertical. This change is connected to how we chew, how we breathe, and even how we speak. So when an ancient ape like Ouranopithecus shows a face that leans toward the human side, it stirs big questions. Was this coincidence, or was it a sign that Ouranopithecus shared something deeper with us? The teeth gave more hints. They were enormous, especially the molars. These weren't the kind of teeth you'd see in an animal that nibbled on soft fruits all day. They were made for crushing and grinding tough foods, roots, bark, seeds, and maybe even bone-hard nuts. The wear patterns on the teeth told stories of struggle, of survival in a land where meals weren't always easy to find. To me, that made Ouranopithecus feel real, not just a fossil in a glass case, but an animal that fought to live in a changing world. And that's another thing, the world it lived in. 9 million years ago, Greece was not the Greece we know today. It wasn't all white stone temples, blue seas, and olive groves. It was a mosaic of environments: patchy forests, woodlands, and open grassy areas. Climate change was reshaping the land. The once lush forests that covered much of Europe were thinning, making life harder for creatures that depended on trees. Ouranopithecus had to adapt. Its powerful jaws and teeth were tools for survival, allowing it to eat foods that others couldn't. Maybe it spent less time swinging through trees and more time on the ground, walking between scattered groves, foraging wherever it could. Some scientists even suggested that its body proportions might have been different from modern apes, that it might have been heavier, more robust, with adaptations for a mixed lifestyle in trees and on the ground. Unfortunately, we don't have enough fossil bones of the body to know for sure. The mystery remains, hanging in the air like an unanswered riddle. But the face that was enough to start a storm. Some researchers saw in those cheekbones and that jaw a resemblance to early hominins like Australopithecus. They wondered if Ouranopithecus could be a distant ancestor, or at least part of the family that eventually gave rise to humans. Others pushed back, insisting that the similarities were just coincidences, convergent evolution, they called it. That's when two unrelated species evolve similar traits because they face similar challenges. I remember reading an argument by one scientist who said, if you give enough time, apes in different regions will sometimes end up looking alike without being related. That made sense, but at the same time, it felt unsatisfying. If Ouranopithecus wasn't related to us, then what was it? Just a side branch, a cousin that lived and died without leaving descendants? Or was it part of a much bigger story, one we still don't fully understand? That's the thing about fossils, they never give you everything. They're like torn pages from an ancient book. You can read what's there, but the missing words force you to imagine the rest. Sometimes the guesses are close to the truth, sometimes they lead us down paths that turn out to be wrong. But either way, they keep us moving, keep us curious. When I close my eyes, I picture the scene, a group of Ouranopithecus resting in the shade of a tree during the heat of the afternoon. One cracks open a hard nut with its massive teeth. Another leans against a branch, its broad face calm, eyes scanning the horizon for danger. The youngest of the group, not yet burdened by the struggle for food, plays with leaves and twigs. In the distance, herds of prehistoric animals graze under the sun. None of them know they are living in a time of transition, a moment when climates are shifting and forests are disappearing. But they live, day to day, just like we do now. That face half ape, half something else wasn't just a fossil. It was a window. For scientists, it raised questions about migration. If apes like Ouranopithecus lived in Europe 9 million years ago, could some of them or their relatives have later moved into Africa? Could the human story have roots in both continents? Or maybe Europe was just one of many testing grounds for evolution, a place where experiments happened, some successful, some not. For me, the story of that face changed how I thought about history. I used to imagine evolution as a straight staircase, monkey, ape, caveman, human. But Ouranopithecus showed me it was more like a sprawling maze. Different species tried different paths. Some hit dead ends. Some survived long enough to pass on their traits. And somewhere, through all that branching and twisting, we eventually appeared. The puzzle of the face isn't just about bones. It's about us, about how much of our story is still hidden, and how even a fragment of a jaw or a cheekbone can shift the way we see ourselves. To this day, scientists debate whether Ouranopithecus belongs in the direct line to humans or not. The arguments fill journals and conferences, and no one has the final word. But in a way, that's the beauty of it. The mystery keeps the story alive. Whenever I think about that fossil face, I feel a strange kind of connection. Not because I'm sure it was my ancestor, but because it reminds me that history is complicated. Our story didn't start neatly in one place at one time. It's older, messy, and more surprising than that. And maybe, just maybe, that wide, flat face staring back at me from a drawing is a distant echo of my own. Sometimes, when I read about fossils like Ouranopithecus, I imagine scientists not just digging in the dirt but also sitting around in heated debates, their voices rising, hands waving, each convinced they've got the right piece of the puzzle. And honestly, that's exactly what happened after the discovery of this fossil. The bones weren't just old, they were controversial. By the late 1970s and into the 1980s, the story of human evolution already had a strong foundation. Africa was the star of the show. From the Great Rift Valley came fossils like Australopithecus afarensis, Lucy, Australopithecus africanus, and later, the early members of our genus, Homo habilis and Homo erectus. These discoveries told a powerful story. Africa was where it all began. Humans were children of Africa, and our deepest roots were planted in its soil. But then there was Ouranopithecus, sitting there in Greece, older than Lucy by millions of years, staring back with its flat face and giant teeth. It didn't fit neatly into the African-centered picture. Some scientists in Europe began asking, could the roots of humanity have first sprouted here, in Europe, before spreading into Africa? That question lit a fire. On one side were the traditionalist scientists who said, no, Africa is still the cradle of humanity. The evidence there is overwhelming. A few fossils from Europe don't overturn decades of work. They argued that Ouranopithecus was simply another extinct ape, unrelated to us, a side branch on the evolutionary tree that didn't go anywhere. On the other side were the challengers researchers who saw in Ouranopithecus something more. They pointed to its facial structure, its teeth, and its age. They argued that maybe, just maybe, this was evidence that the human line began in Europe before migrating back to Africa. They said the story was bigger than one continent, that perhaps evolution's experiments were happening across a wider stage. Imagine those conference halls where the debates happened. One scientist stands at the podium, slides projected behind him showing close-up photos of fossil jaws. He points out the flatness of the face, the massive molars, the shape of the dental arcade. These are not the traits of a typical ape, he insists. These are hominin-like. Murmurs ripple through the audience. Some nod, others cross their arms in doubt. Then another scientist takes the stage, shaking his head. Coincidence, he counters. Convergent evolution. Apes in tough environments evolve big teeth and flatter faces. It doesn't mean they're our ancestors. The audience splits again, the room buzzing with tension. Reading about these arguments, I felt like I was watching a tug of war. On one side, Africa pulled hard, anchored by Lucy and other fossils. On the other, Europe tugged back, its rope tied to Ouranopithecus. And in the middle hung the question, where did the first steps toward humanity really begin? For me, the most fascinating part wasn't who was right or wrong. It was how one fossil could spark such global debate. It showed that science isn't fixed, it's alive, shifting with every discovery. Truth in science isn't declared, it's tested, argued, and sometimes rewritten. What made the argument harder was the lack of fossils. From Ouranopithecus, we mostly had jaws, teeth, and parts of faces. That's not much to go on. Teeth can tell you a lot about diet and lifestyle, but they can't show you how a creature moved, whether it walked upright, or how it used its hands. And those are the features that would really link an ancient ape to humans. Without them, scientists were left arguing over scraps. But scraps can still be powerful. For instance, the thick enamel on Ouranopithecus's teeth was unusual. Most apes today, like chimps, have thinner enamel. Humans, on the other hand, have thicker enamel, which helps us chew a variety of foods, including tough ones. The enamel on Ouranopithecus looked more human-like than ape-like. Was that a clue? Or was it just another coincidence? No one could agree. Then there was the matter of timing. Ouranopithecus lived about 9 million years ago. That's long before Lucy, 3.2 million years ago, long before the first Homo species, about 2.5 million years ago. If Ouranopithecus really was connected to us, it would push the origins of the human line back much further than most scientists had accepted at the time. It would mean there was a whole hidden chapter of evolution we barely understood. I remember staring at the timeline in one of my books. The line stretched across millions of years, with dots marking important fossils. There was Lucy, bold and clear at 3 million years. There was Homo erectus at about 1.8 million. There was Homo sapiens, our own species, appearing less than 300,000 years ago. But way off to the side, At 9 million years, sat Ouranopithecus a lonely dot, far older than the rest. It felt like a whisper from a forgotten age, daring us to fill in the enormous gap between it and Lucy. And maybe that's why the debates about it became so intense. It wasn't just about one fossil. It was about the possibility of rewriting the first chapter of our story. Of course, the African fossils were stronger evidence. They showed clear signs of upright walking pelvic bones, leg bones, even footprints preserved in volcanic ash at Laetali in Tanzania. Those fossils didn't just whisper, they shouted, "Here is the path to humanity." Ouranopithecus, in comparison, was like a riddle scribbled in faded ink. You could interpret it in different ways, but you couldn't prove it. Still, that riddle mattered. It forced scientists to think outside the box, to consider that maybe evolution's story wasn't confined to one continent. It opened the door to a bigger, more complex view of our origins. I like to imagine the scientists themselves in those moments, not just the fossils. Some, pacing nervously before presenting their arguments, clutching their notes, wondering if they'd be ridiculed. Others, frowning in the audience, scribbling down counterarguments. Some probably felt frustrated. Why couldn't the fossils just give clearer answers? And yet, beneath all the tension, there was also excitement. Because whether you believed Ouranopithecus was part of our lineage or not, one thing was clear: it was important. It was changing the way people thought about evolution. And it changed the way I thought too. Before I learned about Ouranopithecus, I assumed science was about certainty. I thought the timeline of human evolution was like a finished painting, complete, neat, and unchanging. But this fossil showed me the truth: science is more like a giant puzzle with missing pieces. Every new piece doesn't just fill a gap, it can force you to rearrange the whole picture. So Ouranopithecus wasn't just an ancient ape in Greece. It was the spark of a debate that stretched across continents, filling conference halls and scientific journals with arguments. It was a reminder that history isn't simple, and neither is science. And maybe that's why I like its story so much. Not because it gives clear answers, but because it reminds us to stay curious. To keep digging, keep questioning, keep wondering if the story we think we know might still be waiting to be rewritten. Sometimes, when I think about Ouranopithecus, I realize that bones alone aren't enough to really understand it. A fossil jaw or a face fragment can tell you about teeth and chewing, but it doesn't tell you what the animal saw when it looked around, what sounds it heard in the distance, or what kind of dangers it faced. To imagine those things, you have to rebuild the world it lived in. 9 million years ago, the land that we now call Greece was nothing like it is today. There were no white stone temples, no villages by the sea, no olive groves or mountain paths buzzing with tourists. Instead, the area was wild, untamed landscapes stretched across rolling hills, rivers, and scattered woodlands. The Mediterranean Sea hadn't fully taken its modern shape yet, and the climate was shifting in ways that would change everything for the creatures living there. Scientists say that during this time, Europe was going through a transformation. The once thick, green forests were thinning. Temperatures were cooling a little, and rainfall patterns were changing. Grasslands were spreading in places where dense trees once stood. Animals that had depended on deep forest habitats were struggling, while those that could adapt to more open spaces were beginning to thrive. That's the stage on which Ouranopithecus lived. I like to close my eyes and picture it: the sound of cicadas buzzing in the heat, the smell of dry earth, a mosaic of landscapes where patches of woodland meet stretches of open ground. A herd of prehistoric horses grazes nearby, their manes flicking as they swat away insects. Strange relatives of elephants, smaller than the ones we know today, wander through the grass, pulling leaves from low trees with their trunks. Herds of antelope-like creatures dart nervously, always alert for predators. And in the branches of the trees or maybe sitting on the ground beneath them are groups of Ouranopithecus. We don't know exactly how they behaved, but we can guess by looking at both modern apes and the fossils they left behind. Their large molars suggest they spent a lot of time chewing hard, fibrous foods. Maybe they cracked open tough nuts, gnawed on roots, or stripped bark from trees when softer fruits weren't available. Their thick enamel hints at a diet built for survival during harsh times, when food wasn't easy to find. Life would not have been simple. Every day was about balance, finding enough food, staying safe from predators, and caring for young. A mother Ouranopithecus might carry her infant close against her body, keeping a watchful eye as she foraged. Older individuals might sit in groups, grooming each other, keeping bonds strong. These small acts of survival, finding food, grooming, staying close, were the rhythms of their lives. Predators lurked, too. Back then, large carnivores like saber-toothed cats roamed Europe. Imagine the sudden silence in the forest when one of them appeared. The group of Ouranopithecus would scatter, some climbing into trees for safety, others huddling together, eyes wide, hearts pounding. The fossil record doesn't preserve those moments of fear, but they were just as real as the bones we find today. And then there was the climate. The shift toward drier, more open habitats wasn't just a backdrop, it was a challenge. Apes that had thrived in lush forests now had to adapt to landscapes where trees were fewer and farther apart. That's why some scientists think Ouranopithecus may have spent more time on the ground than earlier apes. If true, it would put them one small step closer to the kind of behavior that would eventually shape our own ancestors. I find that idea fascinating, that maybe, in those open woodlands of ancient Greece, groups of Ouranopithecus began moving differently, covering more ground, taking risks in open spaces. Maybe they were testing the limits of what it meant to be an ape in a changing world. Of course, not all apes survived these changes. In fact, many species went extinct as the forests shrank. Europe had once been home to a whole variety of apes, but by the time climates continued to cool and dry, most of them were gone. Ouranopithecus was one of the last of its kind in Europe. After it disappeared, apes vanished from the continent entirely for millions of years, surviving only in Africa and Asia. That fact alone makes it special. It was part of the last wave of European apes before the curtain fell on their story there. I imagine what that must have been like, to live at the edge of survival. Each season, the trees grew sparser, the food harder to find. The young would have struggled the most. Some groups probably didn't make it through harsh droughts. And yet, for a time, Ouranopithecus endured. Their fossils tell us they held on in those tough environments, adapting in ways that still spark debate today. The thought gives me chills. Survival isn't guaranteed, not for them, not even for us. Evolution is full of experiments, and not all of them succeed. But that's why the world they lived in matters so much. Without understanding the forests, the rivers, the predators, and the changing climate, we can't really understand the bones. The fossils don't float in empty space, they're rooted in an environment that shaped every part of their bodies. The broad face, the massive jaws, the thick enamel, all of those features were responses to a tough and shifting world. Sometimes I wonder what it must have felt like to be a young Ouranopithecus. Maybe waking up at dawn in a nest of branches, climbing down carefully to follow the group. Maybe tasting a bitter root for the first time, chewing it slowly with teeth that ached from wear. Maybe hearing the distant call of a predator and freezing, every muscle tense, before rushing back to safety. Their lives were not written in words, but their fossils give us just enough to imagine. And when I imagine them, I don't see them as strange creatures separated from us by millions of years. I see them as living beings, full of struggle and survival, much like us. They didn't know they were part of a great evolutionary story. They didn't know their bones would one day spark debates about where humans came from. They were just trying to live, in a world that was constantly changing around them. In a way, that makes them feel even closer to me. Because aren't we doing the same thing now? Facing changes, adapting, trying to survive in a world that never stays the same. The world of 9 million years ago is gone forever, but pieces of it remain: fossilized bones, pollen grains trapped in ancient soils, the shapes of valleys carved by long-vanished rivers. Each clue helps us rebuild the stage where Ouranopithecus lived out its story. And by rebuilding that world, we come a little closer to understanding not just them, but ourselves. The more I read about Ouranopithecus, the more I realized that fossils aren't just dead things, they're tiny windows into lives that were once full of motion. Every crack in a tooth, every curve of a bone, is like a sentence written in a language we're still learning to read. And when you start piecing those sentences together, you don't just get facts about anatomy, you get glimpses of how these creatures might have lived. That's what fascinated me the most, the possibility of imagining a day in the life of Ouranopithecus. Picture this. The sun is just rising over the rolling hills of what we now call northern Greece. A soft light spreads across the scattered woodlands, and the air is still cool before the heat of the day sets in. In a tree, a small group of Ouranopithecus begins to stir. They've made simple nests out of branches during the night, just like chimpanzees do today, to keep off the ground where predators roam. A mother stretches, her infant clinging to her chest. The older juveniles begin to chatter softly, tugging at each other's arms, impatient to move. The group leader may be a strong male, maybe just an older, experienced individual sits quietly, watching the world below for any sign of danger. Soon, the group descends, using both their arms and legs to move carefully down the trunk. On the ground, the day's search for food begins. Food was everything. Their teeth tell us so. With their massive molars and thick enamel, Ouranopithecus spent hours chewing, grinding down tough plants, seeds, and roots. I imagine them moving from tree to tree, stripping leaves, breaking open nuts with their powerful jaws, even digging a little with sticks to find edible roots. When food was plentiful, maybe the group lounged in the shade, grooming each other and resting. When it was scarce, the day stretched into long walks under the hot sun, their broad faces dripping with sweat, their teeth working tirelessly at whatever they could find. And they weren't alone. Other animals filled the landscape, herds of small antelope-like creatures grazing nervously, packs of carnivores stalking the underbrush, massive ancient relatives of elephants moving slowly in the distance. Ouranopithecus had to share its world with all of them. Safety came in numbers. Just like modern apes, they probably relied on the group to stay alive. But what about their social lives? Fossils can't directly show behavior, but we can guess. Most apes today live in groups, whether it's chimpanzee troops, gorilla families, or orangutan communities. Group life means protection, but it also means tension. Males might have competed for status. Females might have formed bonds through grooming. Youngsters probably played together, learning skills they'd need to survive. I can almost hear it, the sound of soft grunts, the rustle of leaves as they move, the sharp crack of a nut splitting in a powerful jaw. A youngster squeals in play, only to be shushed by a cautious adult who's heard something in the distance. For a moment, the group freezes, hearts pounding before relaxing when the danger passes. At night, when the sky turned dark and the stars appeared, the group would climb back into the trees to rest. The youngest clung close to their mothers. The older ones found sturdy branches to curl up on. The night sounds of the ancient forest surrounded them, the distant roar of predators, the chirping of insects, the whisper of wind in the leaves. Sleep was never fully safe, but it was enough to carry them through to another day. What amazes me most is how much of this daily rhythm we can guess from just bones and teeth. A worn-down molar tells us about tough diets. Thick enamel hints at food scarcity. A broad face suggests strong chewing muscles. Even the shape of the jaw tells us something about what they ate and how they survived. Every detail is like a clue, building a picture of lives lived long before humans existed. And yet, as real as they feel in my imagination, I never forget how fragile their existence must have been. Ouranopithecus lived at the edge of survival. Climate changes were reshaping their world. Forests were shrinking. Food was harder to find. Predators prowled. They endured for a time, but eventually, like so many species, they disappeared. Their bones were left behind, buried in the soil, waiting millions of years for us to find them. There's something humbling about that. These apes didn't know they were part of a story that would one day connect to humans. They didn't know that their teeth and jaws would one day be studied under microscopes, debated in conference halls, and written about in books. They were just living one day at a time, facing the challenges of their world. And maybe that's the most human thing of all. Because when I think about it, aren't we doing the same? We wake up, we search for food, though in grocery stores instead of forests, we care for our families, we face dangers, and we adapt to changes in our world. Ouranopithecus lived 9 million years ago, but in some strange way, their daily struggles don't feel so distant from ours. What also strikes me is how much of their lives will forever remain unknown. Did they laugh? Did they play tricks on each other, the way young chimpanzees sometimes do? Did they have calls or sounds unique to their groups? We'll probably never know. Fossils don't preserve laughter. They don't capture the sound of a call echoing through the trees. But I like to imagine it anyway, because it makes them feel less like shadows and more like living, breathing beings. And maybe that's why Ouranopithecus matters so much. Not just because it changes scientific debates, but because it reminds us that evolution isn't just about bones. It's about lives, real lives, filled with hunger, danger, play, family, and survival. Every fossil is a frozen echo of something that was once alive and full of struggle. When I think about their lives, I don't see just ancient apes. I see survivors, pushing through hard times, adapting to a world in transition. In their faces, I see a hint of my own. And maybe that's the biggest lesson of all, that even across millions of years, the line between them and us is thinner than it first seems. For a while, I thought the story of Ouranopithecus was like a mystery book with half the pages missing. There was the jawbone, the teeth, the flat face, clues that seemed important, but then a giant silence where the rest of the story should be. And then I learned that new fossils found years later would suddenly reopen the case, almost like a detective finding a box of forgotten evidence. The 1970s had given us Ouranopithecus in Greece. By the 1990s and 2000s, other fossils began to appear that made scientists wonder all over again about Europe's role in our origins. One of the most talked about was Graecopithecus freybergi, nicknamed the El Greco fossil. It was discovered in Greece, actually first found back in the 1940s but not really studied in detail until decades later. The fossil wasn't much, a single jawbone with teeth, very worn down and not very pretty to look at. But when scientists took a closer look with modern technology, they found something surprising. The roots of the teeth looked unusual, more like those of early hominins, the group that includes humans and our closest extinct relatives, than of typical apes. That tiny detail set off a storm. Some researchers argued that this meant Graecopithecus could be one of the very first hominins, living around 7 million years ago, right at the point when humans and chimpanzees were splitting from a common ancestor. And if that were true, it would mean the very start of the human line might have happened not in Africa, but in Europe. I remember reading that and feeling my heart race. Could it really be? Could the spark that eventually became us have started on the same land where ancient Greeks later built temples and wrote myths? It felt almost too wild to believe. But of course, not everyone agreed. Some scientists said the evidence from Graecopithecus was too thin. A single jaw and a few teeth weren't enough to claim it was a hominin. They pointed out that worn teeth can look misleading, and that many ape species evolved similar features without being directly related to us. They warned against rewriting history on the basis of such limited evidence. Still, the idea lingered. If Ouranopithecus at 9 million years and Graecopithecus at 7 million years both lived in southeastern Europe, maybe Europe wasn't just a side stage after all. Maybe it was part of the main story. And then came another surprise from Africa this time. Around the early 2000s, scientists announced the discovery of Sahelanthropus jadensis, nicknamed Tume, in Chad. This fossil was about 7 million years old, roughly the same age as Graecopithecus. Its skull was small, with a brain size like a chimpanzee's, but its face was flatter, and most intriguingly, the hole where the spine connected to the skull suggested it might have walked upright. The debate exploded. Here was a fossil in Africa, about the same age as Graecopithecus, showing traits that some thought marked it as a very early hominin. So now the tug of war stretched across continents, was the first step toward humanity in Europe, with Graecopithecus and Ouranopithecus? Or in Africa, with Sahelanthropus? I imagine scientists looking at maps, their fingers tracing lines between Greece and Africa, wondering about migrations millions of years ago. Could apes have moved back and forth, crossing land bridges, chasing food, and adapting to new environments? The Mediterranean back then wasn't always a sea as we know it now. During some ancient periods, it even dried up, creating vast plains that animals could have crossed. Was it possible that Ouranopithecus or its relatives traveled into Africa, where they evolved further into the hominins we know so well? The idea was thrilling. It was like uncovering a secret passage between two worlds, one that linked the hills of Greece to the savannas of Africa. Of course, the debates grew fierce. Some scientists dismissed the European fossils as nothing more than extinct apes with coincidental similarities to humans. Others defended them as crucial missing pieces of the puzzle. I pictured those debates like courtroom dramas, each fossil a piece of evidence, each scientist a lawyer arguing their case, the verdict still undecided. And then I realized that's how science works. It isn't about finding one fossil that instantly changes everything. It's about stacking evidence, testing it, arguing over it, and waiting to see which story fits best with all the facts. Ouranopithecus didn't close the book. It kept the questions alive. But what really struck me was how every new fossil seemed to shift the conversation. Graecopithecus pulled attention back to Europe. Sahelanthropus reminded everyone that Africa still held the strongest claim. Then there was Orrorin in Kenya, another fossil around 6 million years old that showed hints of upright walking. Each new discovery was like a chess move, shifting the balance of the argument, never letting the picture stay still. I once drew a timeline on a big sheet of paper, marking each of these